And it's recording. Exercise 2E. So what you've done so far, 2A was angles. So you had to know your year 7 angles again. Reflex, acute, obtuse, supplementary, complementary. 2B was the hardest. Parallel. So co-interior, corresponding, alternate, vertically opposite. That was probably the trickiest one. I'll put a star there. 2A is review. Angles. 2C was to know your triangles. There's only 3 types. Scalene, isosceles, and equilateral. 2D, you had quadrilateral, so 4-sided shapes. You needed to know all 7 of them. Okay, so differences between them all. And then finally now 2E is what we call polygons. So that's a 3-sided shape, 4-sided shape. Polygons means many-sided shapes. Okay? Technically, triangles and quadrilaterals are polygons. We're just now specifically looking at general polygons. So here we go, the definition of polygons. Polygons are shapes with, what did I say last session? Lots of sides, but the sides have to be specifically, starting with S. T. Straight. They have to be straight sides. If you remember the example I gave to you, I said hexagon. I said if I asked you to draw a hexagon, most of you would draw a hexagon like this. 1, 2, 3, 4, 5, 6. That is a hexagon, but that's not what a hexagon has to look like. A hexagon could also look like this. 1, 2, 3, 4, 5. Oh, actually that's a bit hard. 5, 6. That's a hexagon. Okay? But the hexagon that you're familiar with, there's an actual name for it. Specifically, this shape, which you see in a soccer ball, that's a regular polygon. So it'll be a regular hexagon. Okay, so this is known as a regular hexagon. And when we say regular, what it means is that all sides of equal length and equal interior angles. Meaning, all the sides are going to be the same length. So you have 6 sides, all sides have to be the same length. And all the angles in each corner have to be the same. Exactly the same. Okay? That's what a regular hexagon is. Otherwise, if you just said hexagon, I can draw this hexagon, 6-sided shape. But all sides don't have to be the same. So this is 1 side, 2 sides, 3, 4, 5, and 6. So we call that a hexagon. It's a straight line. And it's a polygon, not a curve. Yeah? So 6 sides are the straight. But you can also have 6 sides that have all equal lengths and equal angles. We call that regular. Do you need to know these names? Yes. You do need to know up to 12. So triangle for 3. Quad for 4. Pentagon, so 5, hexagon, which is 6, heptagon for 7, octagon, most people know, 8, and then from 9, 10, 11, 12, I think from here, not all students know, and that's where I tick off the skill in your learning map. If I got the sense that you generally know up to this much, then I would have ticked it off. If I didn't tick off the learning map where you can identify polygons, the names of polygons, this is what I meant. Okay, did you know how to name them based on the sides? Okay, so learning all 12, you demonstrate that through your exercise. That's when I tick that off. Okay, so knowing nonagon is 9, decagon is 10, well, decagon is 11, and then dodecagon is 12. Those are your polygons. Polygon just means straight sides. The number of sides dictates the name. Cool. All right. However, what is the exercise about? The exercise is about identifying and then solving for angles. Now we know that in a triangle, if you add all the angles together, it's meant to equal to 180. And then you learnt that's from 2C. 2D, you learnt that a 4-sided shape, whoops, not like that. A 4-sided shape, if you add all the sides together, they equal 360. And one of the reasonings that we can see is that I can split it from corner to corner. You get 2 triangles. But since each triangle is going to add up to 180, then having two triangles, it's 180 times 2. Hopefully you start to see a pattern now. So on this table, I'm doing a pattern for you. See, one triangle has got 3 sides. One triangle, it's 180 degrees, so one group of one triangle. In a quadrilateral, when you do one corner to another corner, you get 2 triangles. So 4 sides gives you 2 triangles, and we can say 2 groups of 180 is 360. Now let's go to pentagon, so 5 sides now. If you notice the way I cut it, again, corner to corner, and then from that same corner I go to another corner, I now have 3 triangles. 1, 2, 3. So 5 sides gives me 3 triangles. Therefore, the total angle, if I asked you, if you add all the angles together in a pentagon, it should equal to 3 times 180, and Fraser?
3 times 180.
Which is? 540 is correct. Very good. Did you have another question, did you? No? Okay. So 3 times 180 gives you 540 degrees, and so there's a pattern now. There's a pattern that if you know the number of sides for a polygon, you can also figure out the number of triangles. What's the pattern? 3 to 1, 4 to 2, and then 5 to 3. What's the pattern? Is that Piera? 2 numbers in between. It's 2 less. So essentially, if you know the number of sides, minus by 2, that should tell you the number of triangles. See, 3 minus 2 tells you 1. 4 sides, take away 2, tells you there'll be 2 triangles. So that means in the next one, same thing. 6 sides, you minus 2 tells you the number of triangles you're going to get. You're going to get 4 triangles, but if you have 4 triangles, 4 times 180, because each triangle has 180 degrees, if you've got 4 of them, essentially add another 180 to this, and that gives you?
720.
720, very good. And so the skill here is not so much to fill out the table, but the skill is that if I asked you, what if I had a 99-sided shape, 99-sided polygon, and I said, if I added all the angles together, what should it equal to? So you need to have an ability to figure out, if I gave you a calculator, can you work out the total angle? So here's the rule for it. Let's think about what we just did. If I told you you had a 99-sided shape, how many triangles do you expect?
97.
97, because there should be 2 less, right? So it should be 97 triangles, because it's 2 less. I'm going to write over here, minus 2. So that means the total angle should be 97 triangles by 180 degrees. And that should give you whatever it is. Now, I don't know what 97 times 180 is. Anyone got a calculator? Anyone got the answer? 17,460. Someone double check?
Yep.
Correct? Good. All right. So let's write a rule for it then. S, which means the total sum angle. Okay, so that's what the S, capital S, represents. Now, how did I get 97?
39 by 2.
Good. And 99 was the number of shapes, the number of sided shape, right? So we use the letter N for number of sides. Then we minus 2 to get the number of triangles. So that N minus 2 tells you the number of triangles. Then you times that by 180, because each triangle has 180 degrees. So here, this tells you number of triangles. And that should tell you the sum, total sum of interior angles. That is pretty much what you need to learn from 2E. So even if you didn't understand how the formula came about, you can memorize that, but I usually like you to see the pattern. That's where the formula came from. Okay? So this rule you need to know for 2E and then learning to apply it. So I'll do some problems with you on the next page so you can see how you're applying everything that you know so far to solve for angles, because you need that formula for a sided shape that is more than 4. Because you learn triangles, which is 3. Then you learn quadrilaterals, which is 4. But what if I gave you a pentagon, What if I gave you a nonagon? Would you be able to solve angles for it with all the things I've taught you so far? Okay, so make sure to copy that rule down. S is equal to n minus 2 times by 180 degrees. Okay, and the logic to it is find the number of triangles, and we found the pattern is always 2 less than the number of sides. Times by 180. So far so good. Copy it down and then we'll flip over the page to do some problems together. Here we go, 3, 2, 1, let's flip over. All right, I'm gonna just delete all of this so that you don't see the answers. Here we go, delete. All right, let's do a quick, simple problem from your textbook. It says, example 1, find the angle sum of a regular octagon. So regular octagon means 8 sides, and all sides are the same, and all angles the same. Yes, Fraser?
So if there are 8 sides, you put 8 minus 2 to find the number of triangles,
Which is?
6.
Good. And then therefore all the angles must add up to? How would you calculate it?
6 times 180.
Beautiful. So there we go. So to work it out, it'd be 6 times 180 degrees should tell you the angle sum. Now what's that? 6 times 0 is 0. 48, 4. 1080? Yes? Okay, cool. So the total angles means each one here, if you add all 8 of these angles together, they must add up to 1080. Out of curiosity, what if I asked you to find the angle of 1? Because you know the sum of all of them equals to 1080. What if I asked you, well, what's that angle then? In an octagon, a regular octagon, how would you work it out? What do you do? Fraser?
1080 divided by 6. I mean,
Beautiful. Because in a regular octagon, all the angles are the same. Because it's the same, we want to share 1080 by 8 equally. So that's why you can divide it by 8 and it'll tell you. Now, whoever's got a calculator, what's 1080 divided by 8 equal to? I can do it by hand actually. 135? All right, let's check. 8 goes into 10 once, 2, 3, remainder through. Wait, no, remainder 4. Whoops, 8, 6, 4, 4, yeah, 4, and then 5. All right, makes sense? It is 135. Very good. Let's go to the second problem. All right, let's do this. So that was a regular octagon. Here we go. Find the value of A. Here's A. First thing is you need to figure out what type of polygon is this? What type of polygon is this? Can I please have Tejas? What type of polygon? It's a hexagon. Hexagon implies it has 6 sides. So if it has 6 sides, what was the formula again? Let's go with J. I know this has 6 sides. So what's the formula again to work out what the total angle sum is if I add them all together for a 6-sided shape? 6 minus 2, which is 4. So you got 4 triangles, and then how do you work out the total sum? What's the formula? Good. Because each triangle has 180 degrees. If you have 4 of them, 4 times 180, and that equals, you had your notes before, 720. So it needs to all add up to 720. So let's work out all the angles we have. What's this little box mean again? 90. So we got 90 plus 90 plus 150 plus 120 plus 130, and then plus a missing bit. So let's write it in. 90 plus 90 plus 150 plus 120 plus 130 and plus the missing angle that we don't know. It's all meant to add up to 720. See how I'm laying out the problem? So I've got a diagram, I've got my technique, my problem, and now I'm going to solve. Here we go, let's add. 90 plus 90?
180. 250.
This is 250. 250 plus 150. What does that become?
400.
400. And then now you add these two together. 400 plus 180, which is? 580. But remember, you need to add on A, and you need it to equal to 720. So you get up to this step here. You can sit there and count with your fingers, but what's the technique? How do you find A? What's...
A equals 720 minus 580.
Beautiful. Type on your calculator. 720 minus 580, and that equals... Is it 120? No, 140. 140. Yeah, it's 140. Yep. How do we feel? Shh. Sam, thank you. Can I get a show of hands out of those two problems there that you felt at least 60% that you understood? Hands up if you felt 60%. All right, pretty good. That's 2E. Now remember, this is not going to be due until like week 9, okay? Because I'm still working, I'm giving you time to do 2C, 2D. But if you felt that that was pretty good and you like that, remember you can use a calculator. You can start on 2E if you like, okay? But 2C is very specific. It's got triangles. And then 2D is specific that it's quadrilaterals. I need to know that you know how to name them. You know how to draw them with their properties. And then solving is 2CDE, yeah? Here's your last one. I'm just going to delete this. I'm going to give you, I'm going to pause the video. I'm going to give you, let's give you, how long? Maybe 3 minutes to solve for the interior angle. So it's asking in a nonagon, regular nonagon, they want to know one of the angles. That's what they mean. 3 minutes, going to pause the video. Okay, we're back. Now, can I get a show of hands who got the answer as 140 degrees? Good. Now, if you did get this wrong, there is a mistake in the way I'm writing this because I had, remember, don't do that, positive learning environment, don't laugh.
Oh yeah, good job, Rick, good job.
Thank you. I did have a student, or a few students from my senior level that did something like this and they got it wrong. And I had to look at the calculator to see where they went wrong. What's wrong if I type this on a calculator right now? 9 minus 2 times 180. What's the problem? Yes, Pierre. So what does the calculator do? Fraser?
3 times 180.
Yeah. If you type exactly what I just wrote there, you don't put in brackets because we said number of sides, take away 2, then times 180. So the student would do something like this and they type it in and say, sir, it's weird, my answer's wrong. But you got to look back and think about, well, what's the calculator doing? It follows BUDMAS. It would have done 2 times 180 and you would have got 360 and then 9 minus 360 would have been a negative answer.
Negative 350.
Good. And that's wrong. Okay? And the reason why, like Piero had noticed there, it's because you don't put a bracket in. So if you want the calculator to do what you're wanting to do, make sure to put in the brackets or do it separately. Do 9 minus 2 and then equals and then times by 180. Otherwise you should, if you want to do it all in one go, it's okay in one go if you had done this. Divide by 9. You can type all that in one go. 9 minus 2 in brackets times 180 divided by 9, it would work. You would get 140. Make sure to put the brackets in. Because the calculator will do BUDMAS. If you don't know your BUDMAS, you can type it wrong on the calculator. Okay? And that is it, team. That's it for my lesson. Remember, from now until pretty much week 9, it's revision, catch up, making sure that you submit all your work from chapter 2, chapter 1. Okay?